According to the National Electrical Code, a single 20-amp 120/240-volt circuit can supply up to 2400 volt-amps. A single air conditioning window unit typically draws 800 to 1500 volt-amps, while an outlet can draw up to 1800 volt-amps for a 15-amp outlet. It is important to calculate the total load in the circuit to ensure it does not exceed the maximum capacity. Currently, the shed has 2 air conditioning units with an estimated combined load of 1600 to 3000 volt-amps, and 4 outlets with an estimated combined load of 3600 to 7200 volt-amps. Adding another 20-amp circuit would increase the total load to 7600 to 12600 volt-amps, which exceeds the 2400 volt-amp limit for a single 20-amp circuit. Overloading a circuit can cause overheating, damage to equipment, and potential fire hazards. To safely add more outlets and meet National Electrical Code requirements, there are several options to consider. Firstly, repull larger wires, for example, number 8 American wire gauge. This will allow an increase of the circuit capacity to 40 amps, which can support the increased load. Secondly, install a subpanel in the shed. This will provide a dedicated electrical panel with additional circuit breakers, allowing distribution of the load more efficiently. Thirdly, use a dedicated circuit for the computer repairs. Install a separate 20-amp circuit specifically for the computer equipment. When considering wire size and conduit fill, there are several important factors to keep in mind. Firstly, the American wire gauge, or AWG, standard is used to measure wire size. The smaller the AWG number, the larger the wire diameter and the higher the current carrying capacity. Secondly, number 10 American wire gauge wire is commonly used for 30-amp circuits, while number 8 American wire gauge wire is typically used for 40-amp circuits. It is important to select the appropriate wire size based on the circuit amperage and the length of the wire run to prevent voltage drop and overheating. Thirdly, conduit fill refers to the amount of space occupied by wires inside a conduit. The National Electrical Code specifies the maximum allowable conduit fill to ensure proper ventilation and prevent overheating. Exceeding the conduit fill limit can make it difficult to pull wires and can also increase the risk of insulation damage. In this case, the existing 3/4-inch polyvinyl chloride conduit already contains 3 runs of number 10 wire plus a ground wire. Adding another circuit would likely exceed the conduit fill limit, making it difficult to pull the additional wires and potentially violating the National Electrical Code. To determine the exact conduit fill percentage, consult National Electrical Code Table 1 in Chapter 9. When installing electrical wiring, it is crucial to follow the National Electrical Code guidelines to ensure safety and prevent electrical hazards. The National Electrical Code provides detailed requirements for wire size, conduit fill, overcurrent protection, and grounding. It is important to consult the latest edition of the National Electrical Code and any local amendments to ensure compliance. If unsure about any aspect of the electrical installation, it is always recommended to consult with a qualified electrician. Consider the voltage drop when running electrical circuits over long distances. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause appliances to operate inefficiently or not at all. To minimize voltage drop, use larger wire sizes or run shorter circuits. The National Electrical Code provides guidelines for calculating voltage drop and recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. When running multiple circuits in the same conduit, dirting the ampacity of the conductors may be necessary. Dirting refers to reducing the allowable current carrying capacity of a conductor to prevent overheating. The National Electrical Code requires dirting when there are more than 3 current carrying conductors in a raceway or cable. The dirting factor depends on the number of conductors and the ambient temperature. Consult National Electrical Code Table 310.15. B3. To determine the appropriate dirting factor. Grounding is an essential safety measure in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The National Electrical Code requires all electrical equipment and enclosures to be properly grounded. Grounding conductors must be sized according to National Electrical Code Table 250.122. Consider installing ground fault circuit interrupter, or GFCI, protection for outlets in the shed, especially if they are located in damp or wet areas. Ground fault circuit interrupters are designed to detect small ground faults and quickly de-energize the circuit, preventing electrical shock. The National Electrical Code requires ground fault circuit interrupter protection for outlets in bathrooms, kitchens, and outdoor locations. When trenching for underground wiring, it is important to follow the National Electrical Code requirements for burial depth. The minimum burial depth depends on the voltage of the circuit and the type of wiring method used. For example, direct burial cables must be buried deeper than cables installed in conduit. Consult National Electrical Code Table 300.5 for the minimum burial depths. Before digging, it is important to contact the local utility companies to locate any underground utilities. This will prevent damage to underground cables and pipes, which can be dangerous and expensive to repair. Call 811 before you dig to have the utilities located and marked. When installing electrical equipment in a shed, it is important to consider the environmental conditions. If the shed is exposed to moisture, dust, or extreme temperatures, use equipment that is rated for those conditions. For example, use weatherproof enclosures for outdoor outlets and lights. Consider using surge protection to protect sensitive electronic equipment from power surges. Power surges can damage computers, televisions, and other electronic devices. Surge protectors are designed to divert excess voltage away from the equipment, preventing damage. It is always recommended to consult with a qualified electrician to ensure proper installation and safety. An electrician can assess the existing electrical system, determine the appropriate wiring methods, and ensure compliance with the National Electrical Code and local regulations. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If unsure about any aspect of the electrical installation, consult with a qualified electrician. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important for electricians, contractors, and homeowners to be familiar with the National Electrical Code to ensure safe and compliant electrical installations. The National Electrical Code is not law, but it is widely adopted by state and local jurisdictions. Many jurisdictions incorporate the National Electrical Code into their building codes, making it legally binding. It is important to check with the local building department to determine which edition of the National Electrical Code is in effect and whether there are any local amendments. The National Electrical Code is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The National Electrical Code also includes tables and examples to help clarify the requirements. It is important to read the National Electrical Code carefully and understand the requirements before starting any electrical work. The National Electrical Code is a complex document, and it can be difficult to understand all of the requirements. There are many resources available to help interpret the National Electrical Code, including training courses, seminars, and online forums. The National Fire Protection Association also provides a variety of resources, including the National Electrical Code Handbook and the National Electrical Code Analysis. It is important to stay up to date with the latest edition of the National Electrical Code to ensure compliance and safety. The National Electrical Code is constantly evolving to reflect new technologies and best practices. The National Fire Protection Association publishes a new edition of the National Electrical Code every 3 years, and it is important to review the changes and updates to stay informed. In addition to the National Electrical Code, there are also other standards and guidelines that may apply to electrical installations. These include standards from organizations such as Underwriters Laboratories, or UL, the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of these other standards and guidelines and to follow them as applicable. Electrical safety is a critical concern, and it is important to take all necessary precautions to prevent electrical shock and fire. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If unsure about any aspect of the electrical installation, consult with a qualified electrician. Electrical work can be dangerous, and it is important to be properly trained and qualified before attempting any electrical work. There are many training programs available for electricians and other electrical workers. These programs provide the knowledge and skills necessary to perform electrical work safely and competently. It is important to choose a training program that is accredited and recognized by the industry. Continuing education is also important for electricians and other electrical workers. Electrical technology is constantly evolving, and it is important to stay up to date with the latest developments. Continuing education courses can help electricians and other electrical workers learn about new technologies and best practices. Certification is a way to demonstrate competence in electrical work. There are many different certifications available for electricians and other electrical workers. Certification can help to improve job prospects and increase earning potential. Licensing is required for electricians in many jurisdictions. Licensing ensures that electricians have the necessary qualifications to perform electrical work safely and competently. It is important to check with the local licensing board to determine the requirements for licensing. Electrical inspections are conducted to ensure that electrical installations comply with the National Electrical Code and other applicable standards. Electrical inspections are typically required for new construction, renovations, and additions. It is important to schedule an electrical inspection before energizing any new electrical work. Electrical permits are required for many types of electrical work. Electrical permits ensure that the electrical work is performed safely and in compliance with the National Electrical Code and other applicable standards. It is important to obtain an electrical permit before starting any electrical work that requires a permit. Electrical codes are constantly evolving, and it is important to stay up to date with the latest changes. The National Electrical Code is updated every 3 years, and it is important to review the changes and updates to stay informed. Local jurisdictions may also have their own electrical codes that are more stringent than the National Electrical Code. It is important to check with the local building department to determine the applicable electrical codes. Electrical safety is a shared responsibility. Homeowners, tenants, and landlords all have a responsibility to ensure that electrical systems are safe. It is important to report any electrical hazards to the appropriate authorities. Electrical emergencies can occur at any time. It is important to know what to do in an electrical emergency. If someone is in contact with electricity, do not touch them. Call 911 immediately. Turn off the power to the circuit if possible. Electrical maintenance is important to prevent electrical hazards. Electrical systems should be inspected regularly by a qualified electrician. Any necessary repairs should be made promptly. Electrical upgrades can improve the safety and efficiency of electrical systems. Electrical upgrades can also increase the value of a home or building. Consider upgrading older wiring, electrical panels, and lighting fixtures. Electrical energy efficiency can save money on utility bills. There are many ways to improve electrical energy efficiency, such as using energy-efficient appliances, lighting, and insulation. Consider installing solar panels to generate electricity. Solar panels can reduce reliance on fossil fuels and lower electricity bills. Electrical innovation is constantly changing the way we use electricity. New technologies are being developed all the time, such as smart grids, electric vehicles, and energy storage systems. These technologies have the potential to transform the way we generate, distribute, and use electricity. Always prioritize safety and consult with qualified professionals when dealing with electrical systems.